Hello, I'm Igor and welcome to my tech farm. BondTech company sent me some CHT nozzles for the testing, not directly to me but to filament company, and they forwarded them to me. CHT nozzles has some additional channels, and with this the contact area with the filament is increased and the heat transfer will be faster too. Now Stefan from CNC Kitchen did a very good research about these nozzles, and he proved that their maximal flow rate is bigger even from the Volcano nozzles. And my approach is a little bit different, so I'm curious if we can benefit from these nozzles on slower printers, like Prusa MK3 or Ender3 or something similar. Because I hope that maybe the plastic will be melted better and we will have a better layer adhesion. Just to be clear with the numbers, if we use Ender3 and print a benchy with a 0.4mm nozzle, the maximum will be 2 cubic millimeters per second, the maximum flow rate. If we use 0.6 nozzle on this printer, the standard settings we will have 3 cubic millimeters per second flow rate. The maximum is 15. Volcano maximum is 30, CHT 40 cubic millimeters, so we are not even close to that maximal flow rate, but I'm curious if the plastic will be melted better using the same printer, same G-code, same settings, and we will have better layer adhesion or not. I'm curious about this test because I don't know what will be the results. Maybe it will be that there is no effect and the layer adhesion is similar. BondTech accepted this. In this case, the CHT nozzles, we can benefit from them only we are using them on those very fast printers, especially with the bigger nozzle. Let's see what I got here in the package. So in the brown color you can see the nozzles which are sent to me, and this will be my comparison tests on the Prusa printers mostly. There will be a comparison of 0.4mm nozzle, CHT versus regular, and then 0.6mm nozzle, again CHT versus regular. And then CHT bimetal 0.6mm nozzle. Bimetal means that it is copper from the outside for better thermal conductivity, and hardened vanadium steel from inside, which is very resistant. But later I noticed that actually this is not what is inside here, but actually it's the same nozzle, only it's completely nickel plated. And I will compare them with the regular hardened steel 0.6mm nozzle, and on the Ender3 the 0.6mm brass nozzle, coated brass nozzle versus CHT 0.6mm nozzle. Well, actually all I need is to fill this table. The problem is that I have 8 nozzle changes, and after the printing I have 32 pulling tests and then analyzing the results. These are my test objects, and I have several because I want to keep the constant flow rate. Because if I remove this cylinder in the middle, in that case it will slow down in the middle of the objects because of that minimal layer printing time. And if I have only 2 objects, in that case that slowing down will be even bigger. For this experimenting I'm using the Prusa PLA, this is in yellow color, and I'm using the default settings in Prusa Slicer for this filament, which are 215 on the nozzle and 60 degrees Celsius on the bed surface. This is default 0.4mm brass nozzle. First group of test specimens will be marked with number 1. And then I'm placing the nozzle. I will show you only once. So first I'm removing the filament, then removing the part cooling fan, and next is removing the fan shroud. And here I preheated the nozzle to 280 degrees Celsius, and I'm using the 7mm wrench. And later notice for the CHT nozzles I need 6mm wrench. I'm placing back the fan shroud and the part cooling fan, inserting the filament, and this is now printed with the 0.4mm CHT brass nozzle. And this group of objects will be marked with number 2. And then moving to 0.6mm nozzle. This is the regular brass nozzle, 0.6mm of course. This group will be marked with number 3. And now this is the CHT version, brass, 0.6mm in diameter. Marked with number 4. The next printing is with regular hardened steel 0.6mm nozzle. and this group will be marked with number 5. And this is CHT bimetal nozzle. Here you can see the printing process, and of course I'm using the same G-code like with the previous 3 printings. And this group is marked with number 6. And I'm moving to the Ender3 V2 equipped with the direct drive NG MicroSwiss extruder. And I have these 2 nozzles, both are from the BondTech, but this is the regular brass coated, and this is the CHT version. And I will print now with the Creality's CR PLA. I know that I should maybe use the same filament, but the other printing is in progress. And actually, anyway, this is the comparison video where I want to compare these 2 nozzles. Here I also want to show you the nozzle change ones, but it is easier because I don't have to remove the part cooling fan or the fan shroud, only I have to remove the silicone sock. And in the meantime I printed this torque wrench for the nozzle, and I have to use this open-end wrench on the heat block. The nozzle is preheated and I remove the filament, and here I'm using 7mm wrench and then inserting the next nozzle very carefully because it's hot, and here I had to use the 8mm wrench. And now I can insert the filament. And the filament is inserted, a little bit dirty from previous color, which was black, but it is almost ready for printing. Mark with number 7, and I'm moving to the CHT nozzle. Now I notice I have a little bit more stringing than usual, and I forgot that with 0.6 nozzle I have to raise the retraction, but it will be fine. I will use the same G-code with the CHT nozzle too. And this is the last group of objects printed with 0.6mm CHT nozzle. Last group of objects with number 8. 32 test objects, and the smallest cross-section array is 4x4mm, and I will use these holders which are CNC milled by PCBWay. I use their services here. Actually, I presented their services in that review video. And now the measuring part, and I have some new equipment here because some of my neighbors started to complain that the chain hoist is too noisy, especially on the weekends. And with this I have the ratio of 1:3 almost, and I can easily reach those brake loads with my hand. Now I'm not even sure that I should include this into video, but I decided to place it because from statistics I can see that everybody just skip this part and watch only the results, and this is not too good for my algorithm. But anyway, I will include this in the video, but I'll try to speed it up. I was following the brake loads during the test, and there are some really surprising values, especially with the regular hardened steel nozzle, but let's analyze the numbers. And it's time to analyze the data in this Excel table, which you can download from mictechfun.com website. And I changed the order of this table, so it is exactly in that order of the printing. These are my markings, but let's analyze everything on this graph. Prusa 0.4mm nozzle, and here we can see some improvement with the CHT nozzle, but I wouldn't say that this is any significant improvement, so you don't have to jump immediately to this upgrade. Now let's move to the 0.6mm nozzle still on Prusa printer. These are brass nozzles, and again very minimal improvement with the CHT nozzle, but nothing significant. But if you want to print some abrasive materials, carbon fiber, glowing dark filaments, you have to use one of these. And I regularly use the hardened steel nozzle. And of course I know that I have to raise the temperature by 10 degrees approximately, but in case you forget to do it, this is the result. Incredible. I didn't know that the difference is so big. And look at this, with the bimetal nozzle you can print abrasive materials, and the layer adhesion is very similar like with the brass nozzles too. And don't forget, I use the same G-code in all 4 cases. And this is printed now on Ender3 V2. Here I used the Creality CRPLA, but the print temperature was only 210 degrees Celsius. And again, we can see some improvement with the CHT nozzle, 25%. You have to decide yourself, is it worth the upgrade? Well, another big work is finished, and now conclusions. Well, if you don't print abrasive materials, in that case the regular brass nozzle will perfectly do the job, and I'm talking about slower printers only. Improvement with CHT nozzle is visible, but I wouldn't say it is so significant. Now, if you do print abrasive materials, glowing dark filaments, carbon fiber filaments and similar, in that case I usually use this hardened steel nozzle, and I know that I have to increase the temperature and increase it usually by 10 degrees Celsius, but after this testing I'm not even sure is it enough. Maybe there should be a follow-up video to see how much increase in temperature we have to do to have the same layer adhesion. Incredible, with CHT nozzle we can have the same layer adhesion, very similar actually, like with the brass nozzles too. So if you are lazy like me, maybe I will just place one bimetal nozzle and leave it there, so I don't have to swap it if I print regular, PLA and then some carbon fiber or glowing dark filaments inside. Don't forget that this testing was only for slower printers. If you have some fast printer, Voron or something like that, especially if you use bigger nozzle diameter, in that case definitely you will need more flow rate from that nozzle, and this is something what Stefan from CNC Kitchen already tested. I will place a link to his video too. If he has some other experience, then write me a few lines down in the comment section, maybe it will improve my positioning algorithms. Anyway, thank you for watching and happy printing!